Hello, everyone, and welcome to today's SANS webcast in partnership with Dragos, Manufacturing Cyber Threat Perspective. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Selena Larson, Dragos Cyber Threat Intelligence Analyst. If during the webcast you have any questions for our presenter, please enter them into the questions window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Selena.
Great, thank you so much, Carol. Hello, everybody. Thank you so much for coming to hang out with me today. My name is Selena Larson. I'm a Senior Cyber Threat Intelligence Analyst at Dragos. We are an industrial cybersecurity company with a threat detection and response platform, services, for instance, incident response, tabletop exercises, that sort of thing. And then, of course, my team is the threat intelligence team, specifically focused on threats to industrial control systems and hunting bad people trying to take down critical infrastructure. We also focus on helping ICS asset owners and operators stay safe and secure. So today I'm going to be discussing threats to the manufacturing sector. Based on our research, cyber risk to the manufacturing sector is increasing. This is led by disruptive cyber attacks impacting the industrial processes, intrusions enabling information gathering and process information theft, as well as new activity from ICS targeting adversaries. This presentation is actually based on a report that we published last week called the Manufacturing Threat Perspective that has a ton of information. It's a great deep dive into this topic. But today I'm going to be focusing on three key points here. One is the threats. So what are the biggest threats to the manufacturing sector? Who are the adversaries? What are they targeting? How can they have impact to operations? And then you have OT digital transformation. And what does this mean for cybersecurity? How can we make sure that we are keeping our assets, our plants, factories secure? Then finally, defense. How can companies, how can asset owners and operators protect themselves from these threats and have very robust cybersecurity operations? So to get started with the threats, to talk about the ICS targeting activity groups. We currently have 5 activity groups that are targeting or demonstrating interest in targeting the manufacturing sector. This includes Chrysene, Magnalium, Parasite, Wassonite, and Xenotime. Of these activity groups, Xenotime is considered to be the most capable and most dangerous activity group. You might be familiar with this group due to their use of the Trisis malware that targeted safety instrumented systems at a petrochemical facility in Saudi Arabia. These other groups also are not exclusive to manufacturing and have demonstrated targeting in other sectors as well. But these would be the most concerning to asset owners and operators in the manufacturing space. I want to point out here that at Dragos, we don't track actors based on the who or, for instance, the country that's behind the adversary, but rather we focus on the behaviors, the tactics, techniques, and procedures, the infrastructure and the victimology that we observe from these adversaries targeting manufacturing. So to move on to ICS malware, there are currently 2 activity groups, Xenotime and Electrum, that have demonstrated the ability to interact with and disrupt operations with malware specifically targeting ICS processes. Trisis, that we mentioned before, and Crash Override, which was a malware specifically targeting a electric transmission station, can interact with and disrupt industrial processes. Although we have not observed either malware family disrupting manufacturing operations, it is possible that these adversaries will target manufacturing companies in the process of developing such malware, even if they are not the ultimate target. For example, talking about Crash Override. So this was a malware that specifically targeted Siemens Ciprotec protective relays and ABB equipment at an electric transmission substation in Ukraine. So this type of equipment can be found both in some manufacturing facilities in Europe, as well as in the electric operations that support manufacturing facilities. Many large manufacturing operations do run their own electric operations on site. So they will have very similar networks and operations environment to electric operations, utility operations as well. An adversary could theoretically leverage manufacturing operations as sort of a testing ground for disruptive attacks targeting critical infrastructure like electric utilities, again, if the same equipment is used. And of course, we can't talk about threats to manufacturing and certainly industrial control systems threats without mentioning Stuxnet. So this is, of course, the most infamous ICS malware, I would say. And it was first discovered back in 2010. But this was a manufacturing targeting ICS industrial control systems malware. It really was unprecedented at the time, and really the first to cause physical damage to computerized systems. The most common threat to manufacturing is ransomware. It is a very serious threat. We certainly observed a dramatic increase over the last year, and not just to manufacturing, but across the board from an industrial control systems perspective. However, manufacturing, based off of the data that we collected and research that we've done, is highest targeted industry and most impacted by ransomware in terms of industrial control systems. Atkins is a really interesting and unique example, as it is one of the first in a number of ICS aware ICS targeting ransomware strains. So ransomware adversaries are continuing to develop and include industrial processes in the kill lists that they are developing in the malware. So being able to stop the process or stop the functionality of various processes and services related to industrial control systems, not just your sort of encryption schemes on Windows and enterprise software. So these strains that contain this ICS specific mechanisms do represent a unique risk to industrial operations that we haven't previously observed in ransomware. So in 2020, the number of publicly reported ransomware attacks on manufacturing entities has more than tripled compared to 2019. And ransomware operators are increasingly incorporating data theft techniques into their campaigns to further ransom demands. So this is actually pretty interesting. I find that it is part of the ransomware threat, but also part of this sort of supply chain third-party threat that we're going to be talking about here in just a little bit. But what we're seeing with adversaries is that encrypting files, encrypting machines is not enough to necessarily receive their payment. As companies are becoming more adept at, recovering from these types of attacks, the adversaries are responding to that by stealing data and then holding that for ransom, in an effort to sort of further prompt these companies to pay that ransom. However, that opens up an opportunity for other adversaries that might be interested in targeting specific industrial control systems companies, being able to see data on customers or vendors or contractors or some of the equipment that's being used. A lot of the information that's being leaked online isn't necessarily unique or specific to PII, for instance, but it can have some sensitive information that's leaked as well and sort of have these more supply chain implications. Most ransomware strains impacting ICS and related entities are still IT focused, but ransomware can have these very detrimental indirect access on operations and process control networks because it can impact resources like logistics, fleet management, sales operation and fulfillment, or loss of view to resource management tools. So here are some examples of some of the ransomware attacks that we've seen impacting manufacturing. And like I said, it's been a really difficult year for the manufacturing sector in terms of ransomware attacks. AFCO, for instance, was a meat agricultural company, so their production was disrupted due to a ransomware cyber attack, and it actually impacted the employees. They were unable to receive pay. Everest Steel had multiple plant shutdowns throughout North America due to ransomware, and again, the employees were unable to work, unable to get paid for multiple days. An attack in Germany, global mechanical engineering company Netsch was also a part of a victim of a ransomware attack, and the production was disrupted for days. And then in Canada, again, unfortunately, Paper Excellence in Canada also had ransomware attacks that disrupted their paper mills, disrupted their plants and manufacturing operations. So this is just all from this year. And there are a number of other examples that you can use here, but effectively what we're seeing is ransomware has impacts beyond just sort of encrypting files and disrupting sort of business operations. What you're seeing is a potential threat to availability, a potential threat to safety, and then certainly the repercussions of employees and customers and vendors and partners that are also impacted by this threat. So moving on to internet exposed assets. They are widely used for initial access, both from the activity groups that we talked about previously, as well as these ransomware adversaries that are sort of targeting sort of big game hunting, looking for large enterprises to be able to to infiltrate those companies. So industrial networking assets that are exposed to the internet are a high risk for manufacturing that can facilitate initial access into a victim environment. We have multiple activity groups, ICS targeting activity groups, that have previously targeted or currently attempt to exploit remote access technology or internet exposed login infrastructure, for instance. Parasite, Magnalium, and Xenotime, these are all the groups that we mentioned previously that are of interest to these manufacturing asset owners and operators. Alanite is another activity group that we track as well, who has not demonstrated targeting on manufacturing, but does use these sort of internet exposed assets and networking infrastructure for initial access. So last year, 66% of incident response cases that Dragos responded to involved adversaries directly accessing the ICS network from the internet, and 100% of organizations had routable network connections into their operational environments. Adversaries are very quick to weaponize and exploit these vulnerabilities in internet-facing services. You have certainly RDP, remote desktop protocol, virtual private networks, and then certainly critical network infrastructure services like F5, Palo Alto Networks, Citrix, and Juniper. We have seen a lot of these vulnerabilities throughout 2020 coming to light. Oftentimes, it's very difficult to patch them. Sometimes you need, multiple steps are required. Sometimes the only way to sort of fix them is to turn off access, restrict access, or disable the functionality entirely until a patch can be published. And so what we're seeing is these very well-resourced adversaries, but also very quick to identify, develop exploits that can take advantage of these assets. I would also say too, it's not necessarily vulnerabilities that are being weaponized and exploited, but also lack security protocols, right? So, utilizing password spraying campaigns to these sort of exposed assets in order to potentially guess the proper password. Very lax password security, using these sort of default passwords, username and passwords on these exposed devices is another common and useful initial access tool. This has become so sort of prolific that there have been a number of publications by various governments and intelligence agencies that have come out and said, asset owners and operators, you must restrict exposure of your OT assets to the internet. There have certainly been incidents in which internet exposed assets were used for initial access, as was published in Security Week, this event in April. Hackers knew how to target PLCs in Israel water facility attacks. They were able to sort of access those devices due to poor security mechanisms, as well as this case study that we actually worked on in March when we identified parasite activity leveraging a Citrix NetScaler application delivery controller for initial access. Those of you who might be familiar with the CVE, this was 2019-1971. Which was first discovered in December 2019. That was a few months it took between the initial disclosure and weaponization. But if you look at exposed assets using various resources, you can see that there are still a lot of these types of assets that are vulnerable to this vulnerability that could potentially be used for initial access. So despite the patches being made available, oftentimes there might be various reasons why people are slow to patch. It might not be, easy to do so. We might be waiting for the next patching cycle, etc. But what we're seeing is these internet exposed assets are very interesting targets for adversaries. Moving on to ICS specific vulnerabilities. So what my team does is we're identifying vulnerabilities in ICS equipment, and we're actually also assessing and oftentimes correcting vulnerabilities that are published by third-party sources, whether that be ICS CERT or the vendors themselves, certainly independent researchers. But as of October 2020, we've assessed and validated 108 advisories containing 262 vulnerabilities impacting industrial equipment found in manufacturing environments. So that seems like a lot of vulnerabilities, right? And of these, almost half of the advisories described a vulnerability that could cause a loss of view or a loss of control within a compromised environment. So we see a lot of times vulnerable reporting or research, this stuff that comes out about industrial control system specific vulnerabilities and the potential that they could cause, or the potential they have to cause, sort of loss of view, loss of control, disruption within an operations environment. But I want to point out here that of these vulnerabilities that did impact manufacturing industrial equipment, just 70% required access to the victim network in order to exploit, and 26% require an adversary to have access to the vulnerable device itself. 8% actually require an adversary to be on the local area network to facilitate exploitation. So I want to point out here that these vulnerabilities are certainly important. It's really important that they're being reported and identified and hopefully patched as well. But I want to point out here that a lot of times in order to actually exploit them, an attacker already needs to be on the network. They already have had to have past the initial exploit or initial access phase, sort of been able to access your OT environment already. Even being on the box itself, right? Like 26% of these vulnerabilities require an adversary to have access to the device already. And if an adversary has access to the device, they could do a lot more than just potentially exploiting a vulnerability, but theoretically they could use it for other purposes as well without having to mess with any of the vulnerabilities. So in terms of the use of these types of vulnerabilities, if we're talking about ransomware adversaries, which we had mentioned earlier, ICS vulnerabilities may not be useful to ransomware adversaries that generally would not have experience to weaponize ICS vulnerabilities. Despite incorporating ICS-specific protocols into these process kill lists, there isn't a lot of evidence or visibility to suggest that the ransomware adversaries actually know how to engage with and manipulate industrial control systems and the devices within that environment. So this means that, if you want to have a direct or specific impact within an operations environment and be able to sort of modify or exploit an ICS device, that is vulnerable to a potential flaw, adversaries will need to know how this works. How does it interact with the rest of the environment? What types of, how does it communicate? What does it control? And that type of thing. So ransomware adversaries are sort of more traditionally big game hunting. They are going after a lot of different industrial verticals. Oftentimes you see them impacting, for instance, schools and hospitals and a lot of different victims. And they're not demonstrating the ability to sort of weaponize or understand how these environments work. I would also say too that a lot of these vulnerabilities that you're seeing are moot just due to insecurity by default in some ICS equipment. So if an adversary is able to sort of access a specific device or network, a vulnerability might not even matter if the device itself is insecure by design. But what is more of an issue, a great issue, is ICS security problems like default credentials, for instance, overly permissive file shares, allowing people to have access to equipment, services, etc., that they don't necessarily need. And certainly over permissive local permissions, these types of things that could be more useful to ransomware adversaries or your sort of more traditional commodity malware adversaries. So wrapping up on our threats piece before we sort of dive into the IT/OT convergence or digital digitization is IP theft. So operational data is very valuable for a lot of different reasons. IP theft of trade secrets related to process and automation functions can enable industrial organizations and interested states and governments to fast-track development. We do assess with high confidence that this type of activity, including IP theft and industrial espionage, are major threats to manufacturing entities. They can support state-sponsored activities for political or national security efforts. And maintaining material specifications for products is likely not enough to replicate them. Adversaries may want to steal the algorithms, engineering designs, and programming specifications to replicate the entire production process, not just the material, goods, and services output. So this is something that's pretty interesting, and why an adversary might target or be interested in targeting the information and data that lives in an OT environment to facilitate IP theft. Because so much of manufacturing is relying on precision and automation and very specific designs and mechanisms and ingredients, an adversary will need to identify the information that's available on the operations environment, whether that's historian data, for instance, or chemical processing data, the exact amounts of things for pharmaceuticals, for instance, how it's being manufactured and what is being manufactured is just as important as the output itself. And certainly when we're talking about automation, algorithms with AI-based manufacturing processes, that type of thing, is very, very interesting to adversaries who are trying to replicate the entire process and not just the products. So talking about coronavirus impacts and how that might play a role in sort of IP theft threats. This is without a doubt the biggest issue currently facing us, and it is meaning that pharmaceutical manufacturers, certainly healthcare, certainly biotechnology, organizations that are working on the research and development of coronavirus vaccine and other healthcare items that are related to the pandemic are very much at risk for this type of activity. We see from multiple different government sources and intelligence sources that are publicly demonstrating the recent attacks and recent attempts to target the research and development working on COVID-19 vaccine and for intelligence gathering and potentially espionage purposes. There are multiple APT groups from various different state-backed threat actors that are interested in this. But I also want to point out too, it's not just potentially these state-backed actors that are interested in potentially disrupting operations or targeting these organizations. Here on the lower right is an example of a ransomware attack that targeted Dr. Reddy's, which is an Indian pharmaceutical manufacturer that's working with Russia on developing its vaccine. Shortly after this company announced its stage 2 production of a coronavirus vaccine, it experienced a ransomware attack that significantly disrupted its operations. It was very interesting, the timing itself, the extent to which the operational disruptive impacts had is very interesting. You could see why, for instance, a ransomware actor might want to target an entity that's developing pharmaceuticals in a race to help people sort of cure the coronavirus pandemic. So it's very interesting to see, with the coronavirus and the impact that it's having on the manufacturing threat landscape, and we do anticipate this to continue for the foreseeable future. So moving on to discussing third party and supply chain, and essentially kind of discussing how adversaries can leverage these trusted connections between the asset owners and operators and their vendors or their contractors to enable access. So these types of third party connections, whether it's contractors, vendors, etc., often have direct access to operational environments for activities like updates, inspections, or new equipment installations. Enterprise resource planning providers are potential infection vectors that could bridge the IT-OT gap if proper segmentation and security are not in place. ERP services generally require access to operations assets like data historians in order to monitor and store information relating to production, supply chain, inventory, and safety. And if these communications are two-way, any of these sort of trusted connections are two-way communications, it can enable potential hijacking of that trusted connection in order to gain initial access to those organizations. We have seen activity groups that have used compromised vendors and contractors for phishing campaigns, for example. This was with Dynamo and Alanic targeting the electric sector. And Xenotime, again, the activity group that we mentioned earlier, has targeted several original equipment manufacturers and vendors for initial access. Certainly, we've seen hijack connections between managed service providers and their customers, which included a number of manufacturing organizations in the last couple of years. So I would say, too, that oftentimes we think of supply chain and third-party connections as the right-sized chip on a motherboard kind of thing that's implanted surreptitiously in the manufacturing process. But it can be everything from software and services to emails, to business email compromises, to the various connections that you have with your vendor for security updates, for instance. There's a lot of opportunity there for adversaries to sort of hijack those trusted connections for initial access. There's also, an interesting piece here too, that manufacturing entities are part of a global supply chain that support multiple other industries that make them a target for adversaries targeting industries like electric utility or pharmaceutical, both of which we've mentioned earlier during this presentation. Some manufacturing companies' activities stretch into multiple industrial verticals. A really good example of this is Volkswagen's piece here that plans to tap electric car batteries to compete with power firms. So it's kind of a merging of multiple worlds, right? And which will require, different industrial networks and equipment to support. It's also here, what's interesting to me too is just how reliant the world is on manufacturing to support a global supply chain, regardless of the industry. And it's very interesting to me to see, the potential impacts or consequences of manufacturing attacks and disrupting, having sort of ripple effects, right? Like pushing a domino and the rest falling. I wanted to share a story actually that my dad the other day was texting me that he ordered a computer part from overseas, and it was taking a very, very long time. And he had received an email update from the shipper that, due to a ransomware attack on a major shipping and logistics company that was bringing his device from overseas, he couldn't get his computer part. And it was very interesting to think about these giant container ships with loads of goods and products that are coming from a manufacturing facility being distributed via logistics to the end user and the consumer. Each of those pieces are going to have some sort of impact because of a modification or a threat to the manufacturing supply chain. So wanted to talk about network segmentation a little bit, because flat networks are very common in the manufacturing environment. It is really not unusual to see network connections that are shared across both the enterprise and operational segments. This does make it very easy for an adversary to bridge the IT-OT boundary and potentially disrupt manufacturing operations after pivoting from an access point within the enterprise. Some of the major issues are interconnections, again, between IT and OT, just via poor segmentation, maintenance interconnections between environments, and again, the sort of lack of access restrictions. Really, you don't want it to be a free-for-all for any folks to be able to access all of the equipment. And oftentimes the segmentation does exist between enterprise and operations using jump hosts and access restrictions. Manufacturing facilities often leverage the same wide area network connection across all manufacturing plants. So essentially you get your network architecture established, and then you just select all, copy and paste that across all of the different plants or facilities that you have. So certainly that is a potential risk as well. In addition to sort of internet connected process automation and other sort of smart quote unquote manufacturing and industrial Internet of Things type of equipment, operators are adopting Wi-Fi enabled machine tools and diagnostic equipment. This can enable workers to move around plants and factories without tripping over power cords, for instance. Internet connected tools connect to historian databases for quality assurance, regulatory, and logistics purposes, among a variety of other reasons. So while it's great and to be able to provide your workers with lower potential safety risks without having to trip over things, but also just ease of use and being able to get data faster and be able to communicate with all of the necessary devices and each other. Tools that are connected to enterprise or operations resources and use as network access points or targeted in an attack meant to disrupt operations. So the more things are connected, the more of potential initial access or access points that exist within a network. And again, this kind of goes back to ensuring access restrictions, ensuring very secure enclaves where these types of equipment can be connected and separated from the operations network specifically. So just-in-time manufacturing applications and services are very, very crucial. These types of logistics enable moving parts of manufacturing assets, whether that's vehicles, drivers, goods, to communicate and interact with your more static assets like the warehouses or human resources. So there's definitely a lot of moving parts that are very, very reliant on being on time, being very precise, and these all sort of rely on these Wi-Fi internet connections. Employees and contractors will also use mobile and desktop hardware with Wi-Fi connections to use applications and services that are required for their work, as well as for personal communications. They regularly access enterprise and in some cases access operations networks as well. So you have a lot of this kind of going in and out, popping up and disappearing and potentially introducing a lot of different potential for additional communications and additional threats. So one of the issues that we see pretty regularly is a lack of visibility. I kind of use this phrase, sort of building a house without a foundation. If you're trying to, establish a very, very robust cybersecurity team and journey without having, a very strong understanding of the visibility of your network. So connections are increasing, like we were saying, previously with the sort of digitization. But there's a lack of visibility into processes, assets, and communications. And when I say that, I'm not saying, you don't know the number of HMIs, EWS, PLCs in your network, but rather what can communicate with those? What ports are open? Is it two-way or one-way communication? Are there servers that you don't know are communicating with the operations environment? Who has access to the tools and resources and assets that are actually on your network? Should this asset be communicating with everyone, or should it just be communicating with one master asset? So you have, a lot of different communications, assets, and operations that you need visibility into in order to properly defend your network. 81% of organizations that we worked with last year had extremely limited or no visibility into the ICS or OT network. And this is based on observations from incident response engagements. And we found no instances of security and process data aggregation for incident analysis, requiring manual retrieval of logs and distributed analysis. So essentially gaining visibility into that data, aggregating that data can both be very proactive in terms of defense, as well as improve reactive efforts when a particular event happens. So now to kind of go over some of the defensive recommendations that we have. I really did want to give a shout out to MITRE ATT&CK for ICS here. Dragos did help with the development of this along with multiple other security companies. So major shout out to MITRE ATT&CK for putting this together. If you're already familiar with using MITRE ATT&CK for enterprise, then you'll know that the framework can be very, very useful, whether you're just starting out on your cybersecurity journey and developing the team and processes and procedures for that, as well as those of you who have very robust cybersecurity teams, SOCs, leveraging threat intelligence, etc. So this is a very, very useful framework, and it enables you to look for threat behaviors and known tactics, techniques, and procedures that adversaries are targeting manufacturing use. Again, the MITRE ATT&CK for ICS is a very useful sort of map and framework that you can kind of go through and say, all right, what types of adversaries are using what types of behavior in operations environment, and is it possible for us to defend against it? Are we currently already able to do that? So just a quick shout out to MITRE for that. So manufacturing is a very large umbrella that has a number of industries underneath it, right? So we've been talking, very manufacturing in sort of a broad a sphere here, and so defensive recommendations might change depending on the various restrictions or regulations that an organization might have, and so it's not all are created equal. But I did want to include 4 very important defensive recommendations that all manufacturing entities should adopt. And we have, again, the paper that we published recently has a number of additional defensive recommendations that I think are very useful as well, but these are kind of the 4 key ones that I wanted to call out. So it's very, very important to ensure an understanding of network interdependencies and conduct crown jewel analysis to identify potential weaknesses that could disrupt business continuity. Again, it's kind of goes back to gaining that visibility, understanding what's on your network, figuring out what are those crown jewels and what are some of the consequences that could occur if they are compromised or otherwise disrupted. And then you can kind of use that sort of crown jewel analysis, crown jewel defense to build sort of resilient cybersecurity across the network, focusing on the crown jewels. So ensure networks are segmented to the greatest extent possible. Again, I harped a lot on network segmentation in this presentation, but it's very, very important. And you really want to ensure emergency response plans are well documented to detail segmentation efforts in case of an emergency. So if it's not possible to segment your network at all times, you should implement firewall rules that enable you to segment critical ICS components from the network. They could be activated and deactivated depending on the safety and security of the environment and any potential malicious activity. So just doing as much as you can that is possible. Certainly, a well-segmented network is very, very important. But again, there are ways and opportunities to be able to do it temporarily, for instance, to ensure very robust security in the event of an emergency. So services and equipment that are not needed for real-time communications or direct access to operations should be virtualized. This can improve vulnerability management and enable improved security for interdependencies. And then you also want to isolate equipment and services that are used for building access control and heating, ventilation, and air conditioning, so back and HVAC. These services can be considered secondary or support systems that are critical to maintaining safe, reliable manufacturing operations and considered potential targets for adversaries seeking to disrupt manufacturing production. This is one of those things I think that can be very easily forgotten, certainly, but building access control, right? You want to make sure that only the right people are able to access the plant. You want to make sure to be able to see who's coming and going. Certainly with HVAC, for instance, you want to make sure that things are kept cool, both the actual manufacturing process, the servers that are required for this work, as well as the workers and the safety of the workers, right? Ensuring that chemicals aren't being removed from the air, and people are staying safe and healthy in the environment itself. So these are kind of sort of secondary or support systems, but they are just as crucial when it comes to operations. So that was my presentation that I had for you all today. Thank you so much for coming to hang out with me, and I'm happy to take any questions if anyone has any. If you don't want to ask on the webinar, you can totally hit us up, info@dragos.com. I'm also all over the interwebs, so you can find me there as well if you wanted to continue the conversation. But do we have any questions?
All right, thanks for that great presentation. We have some questions ready for the Q&A. However, if anyone has a question for Selena, please enter them into the questions window now. Our first one asks, it came about, 10 minutes into the webcast. It says, for the ransomware with manufacturers, was the malware on the ICS or did it interrupt operations by taking down the IT only?
So that's a great question, and the answer is it depends. We have actually seen incidents where ransomware was able to impact the operation specifically directly from the internet. For instance, you're talking when we mentioned the sort of exposed assets. So we have seen, for instance, RDP uses an initial access for operations, and it did actually impact multiple ICS devices and equipment used in the targeted facility. Again, when we're talking about Ekans or other of the ransomware that had this sort of ICS-specific process kill lists, they are able to sort of identify and potentially stop processes related to ICS if they're able to access the operations environment. And also what you see a lot of times is gaining access to domain controllers, Active Directory, and oftentimes those are not well segmented or differentiated from enterprise to operations. And so an adversary might be able to sort of push out the ransomware via DC compromise to both of those networks. But then on the flip side too, we do see that oftentimes IT impacts will have the disruptive effects on OT just because of the reliance of software and services that are kind of thought as business functions or enterprise functions that are integrated within the OT. So yeah, the answer is it depends, but we have seen both.
All right, thanks. For the ICS vulnerability slide, does that imply that 30% of the vulnerabilities do not require access to the network?
No, so that was I'm trying to think of how what the slide was. I'm so sorry, it's like paused. But no, so that is just based on the vulnerability assessments that we have done through 2020. And oftentimes it means that, they either require local access or network access, right? So if we're talking about on the critical vulnerability scoring system score, the attack vector will either be local or network. So that is not to say that all of them do, but I think that was just they either need network access or additional levels of access. But we did expand on that in the report itself that you can find on the website.
All right, thank you. Have you seen any currently active APTs working on attacks over air gaps?
So none of the activity groups that we track currently targeting industrial control systems are leveraging, sort of techniques to sort of bridge the air gap. There have been some interesting pieces of research come out throughout 2020 that kind of talked about USB malware that is trying to infect those sort of the USB and related devices very specifically, which could theoretically be used to bridge air gaps. But again, there hasn't been really any evidence of that occurring, and we haven't seen that from the activity groups that we track. Certainly, USB malware, that type of thing, has been used before in some attacks on critical infrastructure. But in terms of the activity groups that we're seeing, not really. And also, when you're talking about air gaps, we find that oftentimes people will think that their networks are air gapped, and they really aren't. There are going to be some connections in there that again is really, really important to make sure that you have that visibility in your network, because more often than not, you're going to identify something that you didn't realize was communicating. And perhaps a device that should be there, or the access again should be restricted, or even just restricting different communication ports itself, right? So so I would advise to definitely take a look, and if you're thinking that we have an air gap, certainly take a look at that and make sure that you do have the correct visibility when it comes to that sort of thing. But again, the research on USB malware this year, there's been a couple, and while interesting, doesn't necessarily mean it's specifically targeting air gap networks.
All right, thanks. Someone says, thank you so much for the presentation. It was awesome. All right, and
Thanks for coming.
the next question asks, how do I know or define that a system is OT/ICS?
Well, so IT versus OT, right? So IT is information technology, OT is operations technology, and then ICS is sort of industrial control system. So the operational technology is sort of an umbrella term that we use for technology that controls the industrial processes. So you can think of OT, for instance, an engineering workstation that's running a Windows operating system, right? So it's Windows OS, which you would find in IT, but it is controlling the operations that are required, on the engineering workstation. Versus industrial control systems, these are going to be things like field devices, programmable logic controllers, that type of thing. And so oftentimes at different different facilities, you might have different security teams, right? You're gonna have your OT security team. You're gonna have your engineers and operators, and then you'll have your IT team, which are the folks that are working on information security for the enterprise. And there's actually a really great talk by my colleague Leslie. You can find it on YouTube. Leslie Carhart talked about Confessions of an IT/OT Marriage Counselor, where she discusses, some of the differences in between these two different security teams and how you can kind of, come together and sort of bridge these gaps, whether it's knowledge gaps, communication gaps, and really create a sort of robust security team that addresses the needs and requirements from both sides of the house.
Thank you. Other than ransomware, what is the next most common malware family commonly seen?
Oh, I don't even know. That's a good question. I don't know. I think it depends. I mean, it depends on like if we're talking about victimology. You know what though? I would say that there is still sort of these older malware worms. I don't want to say that it's very common or like second to ransomware. That's not at all what I'm trying to say. But you will often find malware strains that are older, like Configure, for instance, that have oh my gosh, over like a decade old, and it's still sort of worming its way through industrial operations just due to the type of security that you see in some of these environments, right? Like some of this equipment is still running very, very old versions of Windows, doesn't necessarily get the most up-to-date patches. So you see sort of some of these older sort of malware worms that don't actually really do much when it comes to impacting the operations, but they will appear. But Emotet is another huge one that actually fell off a little bit in 2020, but it definitely came back throughout the latter half of this year. That's a Trojan that is a dropper for other malware. Certainly you see a lot of Emotet and Reeve ransomware combinations, but Emotet is something that we see pretty regularly. And then TrickBot, which was the banking Trojan, that was another one that you've seen sort of targeting a lot of various industries, and certainly not just manufacturing, but with the takedown of from Microsoft and Cyber Command and stuff that's dropped off certainly in the last month, but still there. So that's a tough question. I wish I knew the answer actually off the top of my head.
All right, well, thanks for taking a shot at it. Any reported OT attacks with physical damage reported?
Like OT cyber attacks, you mean? So certainly Stuxnet is a great example of that, right? Having actual physical impacts to the operations. I guess it really kind of depends on how an entity or organization is going to define a physical impact. Certainly Trisis was an example of having equipment sort of fail safe. So that had a direct impact within operations. But in terms of I guess if we're talking about like ransomware sort of compromising safety or something, I don't think I am aware of any of that. I don't want to say that it doesn't exist, but I am not aware of
Okay, thank you. Can VPN or VLANs be a vector of ransomware or other viruses into the ICS/SCADA?
Definitely, if it is exposed, or if you have those types of connections, and if certainly, as we're seeing with coronavirus, a lot of people are beginning to work more remotely, establishing sort of virtual access, remote access to ICS that hadn't necessarily been there before. And unfortunately, if these login portals aren't well defended, or again, if it's using commonly used passwords, not having multi-factor authentication, not having very robust security protections in general, you will see them be targeted by various adversaries in an attempt to gain initial access, certainly. Oftentimes it's targets of opportunity, but oftentimes it is, if you are targeted, like Parasite, for instance. Parasite is an ICS focused adversary, and they have used vulnerabilities in VPNs to attempt exploitation of victims.
Thank you. Can devices with default vendor passwords be used to pivot to more valuable targets? Is it common?
I'm not necessarily sure that I have, like hard numbers on that, but certainly default passwords are a very real risk to industrial operations. You have tons of, you have, a number of devices, right? Like potentially hundreds of PLCs, for instance, and it's very common for operators to just continue using the default username and password just because of the amount of work that it would take to change each piece of equipment to its own username and password and update it on a regular basis to comply with, for instance, security policies of the organization. So it's a lot of work. So you do see it very often that you'll have default usernames and passwords. But I mean, certainly like any pivot point, if an adversary is conducting lateral movement, for instance, and they're able to log into an engineering workstation or HMI via default credentials, that's certainly an avenue for further potential attacks.
Thanks, Selena. The next one says, as I understand, patching ICS assets is a decision not to be taken lightly, as there might be other solutions to mitigate, it says, of vulnerabilities, or maybe a vulnerability. What would you suggest to take as a basis for a decision to patch or to find another way to mitigate?
Yeah, so that's really a question about risk, right? So you really want to make sure that you're weighing all of the different variables that go into the type of risk that you're willing to accept as an asset owner and operator. Certainly when it comes to industrial control system vulnerabilities, there are a lot of different requirements, I guess, when it comes to ICS versus IT, right? Like you can't just patch your box overnight. It requires a lot of testing. It requires oftentimes a lot of downtime. What you'll see in industrial environments certainly is these sort of 6-month patching cycles where they'll kind of just build up the vulnerabilities and then do it all in one fell swoop. It really depends on the level of risk that you're willing to accept as an organization. But to your point, there are ways that you can sort of practice this idea of like defense in depth, right? So restricting various ports and protocols, ensuring that only the devices that need to be communicating with each other are doing that, ensuring access restrictions, right? Like only give people limited access to the device or service, and certainly ensure that administrative access is even more tightly restricted. So there are ways that you can ensure that the potentially vulnerable devices are well defended, even if you can't necessarily patch them.
Thank you. Are threat groups' typical intent to interrupt industrial processes or infect products that then can be exploited at an end user?
So again, it depends. for the most part, the activity groups that we're seeing, for instance, with Trisis and Crash Overhead, these were specifically targeted to the environments themselves. And in the case of Crash Overhead, it had a disruptive effect and led to a blackout in Kiev, Ukraine, for about an hour. And then in the case of Trisis, that was targeting the safety equipment. And although it failed safe, it could have had impacts to the environment itself, whether it was the safety of the workers or the potentially an environmental impact. So that's what I would say to that end. Certainly with ransomware, I think that there's a little bit they're kind of cruel. I guess I would call it ransomware adversaries like pretty cruel, because they do have a lot of impacts that go beyond just the company itself, like the workers, for instance, or people receiving the items that they've ordered, or when it comes to healthcare, for example, that's a huge issue that we're seeing. So, but yeah, with the malware that we're seeing necessarily is more targeted towards the environment.
Thanks, Selena. This last one says, is multi-authentication an effective deterrent to malevolent actors? I've heard that multi-authentication is not the most effective security measure anymore.
So yes, it is good. It is very important. So multi-factor authentication is very important. However, SMS-based, so text messaging-based authentication isn't necessarily as robust, for instance, as having an authenticator application, or for instance, a security key, like a physical security key that you carry on your person and have it as your second factor. So I would say that yes, MFA is very important. It is a very useful tool in deterring adversaries. However, depending on your threat model, SMS-based, so text messaging, two-factor authentication might not be the best or most the best route to go, just due to some potential vulnerabilities or the ability to sort of manipulate like telecommunications infrastructure and potentially intercept text messages. So again, that kind of goes back to assessing your risk and conducting your own sort of threat models. But yes, multi-factor authentication is very, very good, very important. The best is a physical security key. If not that, an authenticator app. And then, if not SMS-based multi-factor authentication.
All right, thanks. And another one popped in. It says, what are the typical types of actors do you see attacking local, county, and tribal waters, utilities, or smaller water utilities?
Oh, that's a good question, actually. So what we're seeing a lot of is ransomware attackers tend to target those sort of SLTT organizations. We haven't, or at least there hasn't been publicly documented events of a ransomware adversary having an impact on the safety, availability, or flow of water. However, we have seen some utilities be impacted in terms of not being able to have payments. The customers can't pay. There has been the facilities, the headquarters themselves being locked up and ransomed. But we haven't seen a real operations impact when it comes to water utilities at that level. And it's largely ransomware when it comes to SLTT.
Oh, and another one just popped in. Organizations, or are they state sponsored? Sounds like a follow-up.
Sorry, what was the first part of that question?
Sure. It says, are they criminal organizations or are they state sponsored?
Oh, in regards to ransomware. So that's a good question. Generally, ransomware adversaries are considered to be criminal elements. There have been some reported events of possibly state-backed actors leveraging ransomware in their operations, but currently they are lumped under the sort of cyber criminal umbrella.
All right, thanks. And that's all we have for today, and pretty close to all the time we have. Thank you so much, Selena and Dragos, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.